This award connects very fundamental basic science on a class of enzymes called tyrosine kinases that control the growth of cells and how they actually work as protein machines. It turns out many of these genes are the drivers of cancer cells, and the work that I was a part of led to the development of drugs that can be used to treat cancers that have mutations in these kinase genes. So it's all connected from the very beginning of laboratory work to the patient. When we began our work testing the first drug that inhibited one of these tyrosine kinases back in the late 1990s, there was only one such drug. Today, just 15 years later, there are now 30 or 40 different drugs which inhibit different members of this tyrosine kinase family. It's completely transformed the way we treat cancer and the way pharmaceutical companies think about the next generation of drugs to treat cancer. It's been a revolution. What I think is really remarkable about this trio of investigators is we collectively span the very fundamental part of discovering what are tyrosine kinases, to how they work, and how to use that information to make drugs. And it reinforces the importance of society and governments making an investment in the very basic science of biology, including cancer biology, in order to provide the insights needed to develop these exciting new drugs that are changing the lives of patients today. It's very important in this modern era of cancer drug development to understand the language of basic cancer biology as well as drug development. What these kinase inhibitors have taught us is that each patient's tumor is distinct and needs to be understood at a level that we call genomics, where we sequence the DNA of the tumor. That information identifies the kinases that are all abnormal in that tumor and helps us choose which kinase inhibitor would be most appropriate to treat that cancer.